All right, so now we're going to do an exploration about parallel lines. So on the graph right now, you have two graphs that have already been done for you. Let's check and make sure that they're accurate. We have graph line A is 3x plus 2, y equals 3x plus 2, and there's my y-intercept of 2. It goes up 3 over 1, so it is accurate. Line B is at y equals 3x minus 4. So here's a negative 4. It went up 3 over 1, up 3 over 1. So they have been graphed accurately. So what do you notice about these lines? Well, the title of the section is called Parallel Lines. So what do you notice? You notice that they are parallel. The lines are parallel. Okay, what is the slope of line A? Okay, so if we go back up and look at our equation, what is the slope? M is 3. What is the slope of line B? Go back up and look at the slope. It is also 3. Okay, so that's kind of something interesting. Notice they made the same slope. They're both 3, and that meant they were parallel. Okay, they're the same steepness. So let's see what happens with our graphs here for number 4. And you might want to pause and get some different colors here so that we can identify which one is which. So this first graph, number 1, I'm going to graph using green. I'm going to make some work here off to the side in case I make a mistake. I can go back and fix it. So it's y equals 1/2 x. Oops, there's an x missing. Interesting. 1/2 x plus 4. So m equals a negative half. B equals 4. So at 0, 4 is my first point, and then I go down 1, right 2, down 1, right 2, and I want to do that a few times. I could also go up 1, back 2, just to continue that, and you need your ruler. These need to be nice and accurate. So if I've done it a few times, I can feel pretty good about drawing my line pretty accurately. All right, so green, in my instance, is line 1. Okay, let's do line 2. You can pause if you would like and come back and check and see if you did it right. So my line 2 is y equals negative 1/2 x. It almost looks like there isn't a y-intercept. The slope is still a negative half, but why is the y-intercept? Well, it's like having a plus 0 there. So the y-intercept is 0. It's the origin. So we start at 0, 0. We go down 1, right 2. I'll do that a couple of times to get my line so I know it's going to be accurate. Okay, and there's that one. Alrighty, number 3, I'm going to do an orange. Let me label this one line 2. And then line 3, there's an x missing again. Goodness. Y equals negative 1/2 x minus 4. Can you predict what's going to happen? M is a negative half. B is at negative 4. So we go down to negative 4, and then we go down 1, right 1. Is it parallel? Yep, sure is. And if you did them nicely, you can tell mine are just a teensy bit off, but if you did them nicely, you should have 3 parallel lines on your paper. Okay, so let's talk about this. What do you notice about these 3 lines we just did? They are parallel. Do all lines have the same slope? Did they all have the same slope? Yes, they did. They were all a negative half. Are linear equations that have the same slope always parallel? Yes, as long as the y-intercepts are different. If it was the same y-intercept, it would be the same line. So then it says write 3 equations that are parallel. So you're going to pause it right now. You're going to write 3 other equations that are parallel. Okay, so you should have your 3 equations, my 3 equations. I'm going to pick a 4th x. Okay, I don't know why, I just picked it. And then I can pick any other y-intercept. So minus 2 plus 5 minus 100. There we go. They're all parallel. Okay, we're going to continue on and talk about perpendicular lines. So on the next page, we want to first talk about what it means to be a negative reciprocal. Well, before we get to negative reciprocal, let's refresh what a reciprocal is. So if I said, what's the reciprocal of 1/3, you would tell me it's 3/1. A number times its reciprocal is 1. So if I multiply these two together, I get 1. It would be 3/3, which is 1. So a reciprocal is the flip of it. You guys like to say the flip of it. What's the flip of 5? 1/5. But it doesn't say just reciprocal. It says negative reciprocal. So we need to put a negative sign in front of it. So when I look at number 2 and it says what's the negative reciprocal of a -4th? Well, the reciprocal of 1/4 is 4/1. I can just write 4. But it was already a negative, so I need to take the opposite of that, which is +4. So the negative reciprocal of -1/4 is +4. All right, now what we want to do is we want to look at the two equations graphed here. And that negative reciprocal is going to come into play here in a second. So we have line A and line B, double checking to make sure they're graphed correctly. Then down underneath there it says, are the two lines perpendicular? What does perpendicular mean? It means that they meet at a 90-degree angle. Do those meet at a 90-degree angle? Definitely. So yes, they are perpendicular. Now the question is why? Why are they perpendicular? What about these equations made them perpendicular? Look at the slopes. This slope is a -3. This slope is a +1/3. Are the slopes negative reciprocals? Oops, +1/3. Yep, they're negative reciprocals. So that means the lines are going to be perpendicular. So are the two lines perpendicular? Yes, because the slopes are negative reciprocals. That's why they're perpendicular. So write an equation of a line perpendicular to this one. Y equals -2/3 x plus 4. So it'd have to be y equals, let's flip it. So it'd be 3/2, and since it was negative, this one would be positive. So y equals 3/2 x plus, and then you can make up any other y-intercept you want. So I'll say +2. You could have said -3 or anything. Okay, so on the next page, a little bit different. This time, they want us to write a linear equation that's perpendicular to the line that's already graphed. And it also has to pass through a certain point, and the certain point is 0, -2. Okay, so there's 0, -2. So I need to make a line that passes right here and has to be perpendicular to this guy. So I need some kind of equation like this. Something like, oh, about right there. Okay? Well, it's not going to be eyeballing, and it's not going to be just guessing and checking like that. So what we're going to do is we're going to break this down. The first thing we need to do is we need to find the equation of this line. They didn't give it to us. Well, we know that y equals mx plus b. So the b is easy to find right now. He's 2. So it's going to be +2. We just need to find the slope now. How did we go from here to here? We went a rise of 1 and a run of 2. Up 1 over 2. So that slope is 1/2. So the line that I already have has an equation of y equals 1/2 x plus 2. The equation that I have to give now has to be perpendicular to that guy. So my slope of this equation is a 1/2, but my negative reciprocal, my perpendicular slope, and the symbol for perpendicular is an upside down T. So my negative reciprocal, my perpendicular slope, is going to be a negative, because this was positive, and then flip this guy over, -2. So that's my new guy. And it has to go through the point 0, -2. So its equation is going to be y equals negative 2x plus negative 2 or minus 2. And now we have to draw that one in. So I'm going to put this one in orange. We went down to negative 2, and then we go down to right 1. We could have gone up 2, back 1. And that's going to be my perpendicular line right there. And that's the equation of my perpendicular line. And if you took your protractor and measured it, you would see that that's 90 degrees right there. All right, we're almost done. We just have a couple questions at the bottom. So number 6 says, what is the relationship between the following lines? Parallel, perpendicular, neither. They're already in slope-intercept form, and we know the key is to look at their slopes. So m in this one is 2. M in this one is 3. So the relationship is nothing. They're not same, and they're not negative reciprocals. So it's neither. All right, then number 7 says, write the equation of one line parallel to the equation and one line perpendicular. So parallel to this guy would be the same slope. So it would be y equals 3x, and then we have to pick a different y-intercept. What's the y-intercept of this one? It's 0, so we just pick any other number. So I don't know, whatever you want. Minus 10, I'll say. You can do whatever you want. A perpendicular line has a negative reciprocal slope. So if this one's 3, what's the negative reciprocal of 3? It's a negative 1/3. And then you have your x, and you pick any other number you want. I'll just say plus 2 this time. All right, so that's the end of our parallel and perpendicular line exploration.